Hey everyone, we are going to be taking a look now at chapter 3 in your text, which is going to work and focus on something that we've talked about a little bit already, and that is the normal distribution. We've seen already how we can take a histogram and start to look at its shape and see like, well, this is pretty symmetric. What we're doing in a normal distribution is we're saying that, specifically in a normal distribution, the mean and the median are almost identical. I mean, I guess to be perfectly normal, it would have to be exactly in the middle. All right. What we're going to talk about before we get to that is this model right here. They've taken this and they've tried to model the graph that we have. And that model is referred to as a density curve. All right. The reason that we use a density curve is because it allows us to have something that is a regular shape. I mean, it's a shape that we can find the area of underneath. So let's give an example like they use this in the book. They start out with a really weird looking curve, but it's a density curve. It has a baseline of 0. It has a height of 1/3, and it is 1, 2, 3 units long. The idea is that just using normal measurement, I can find the area under that curve right there that I've highlighted. From 0 to 1, I can find that area because it's 1 times 1/3, which I apparently pressed something. 1 times 1/3, which equals area of 1/3. If I kept this going on over to here, let's say this is 1.5. I could find the percentage of people that I have here by doing the area. I could say, well, 1.5 is really 3/2 times 1/3 ends up being 3/6 of the data, which you probably would recognize immediately as, well, 1.5 is halfway through, so that's 50%. All right. Two things that have to be true about a density curve is it has to have a baseline at 0 on the horizontal axis, and the area underneath a density curve has to be equal to 1. So that's why I said 50%. The total area under a density curve is equal to 1. They use 1 because they're talking about 100% of the data. All right, so that's why I chose these numbers. If you look at it, 1/3 and 3, when I find the area of the entire thing all the way across, from 0 to 1/3, I would do 3 times 1/3. It ends up equaling 1. So that's the good news. Equals 1. It's really easy to work with. Bad news is finding the area of a shape like this requires calculus. All right, but since we're not doing calculus, we're going to do that in statistics. We're going to use things that are called z-scores in order to do that. But the idea is the entire area equals 1, or I like to think of it as 100%, but it's 1. We are going to be able to say, like, well, in this one right here, because it's symmetric, perfectly symmetric on both sides, if this is halfway through whatever the data is, I'll just say this is halfway, then the area over here, when we use calculus to figure out the area over here is going to equal 1/2 or 0.5 or 50%. All right. So I think you can start to get an idea of some of the things that you're going to be using this to find. You're going to be able to, say, in a normal distribution, you're going to be able to find things like what percent, like let's say this ends up being about 16% from whatever this end is over to here. All right. You'll be able to do the same thing over here and say like, oh, maybe from this portion on, this ends up being about 33%. This shows, let's just put some numbers in here. Let's say this is 2, and this is 5, just arbitrary numbers. This says that 33% of the population or sample is greater than 5. All right. This says 16% is less than 2. All right, 16% of the people or population ends up being less than 2. All right, so that's where we're headed with this, and the idea is going to be getting into those z-scores. So the last thing I want to point out, and they talk about this, and it maybe doesn't always make the most sense, and it might not be the most important thing, is that not every distribution is a normal distribution, but that doesn't mean we can still have a density curve, this one prepared by a computer, that graphs this data, but notice in a case like this, it doesn't have a perfectly symmetric shape. So this one's not. It's a density curve, yes, but it's not a normal distribution. The other thing to keep in mind is with any of these distributions, they give you some examples about the mean. So that's a pretty poorly drawn one. Let's say that's normal. The mean, or excuse me, the median, capital M, and the mean. And when we do density curves, we end up taking mean and we use the Greek letter mu in order to describe that. So the mean and mu ends up being right in the middle in the normal. They're right at the same spot, and that's not perfectly in the middle, but I think you get the idea. The other thing to remember, and the way that they kind of display this is in ones that ends up being skewed a little bit. So let's say we have one that ends up being skewed a little bit. All right, there's a density curve. The median is the middle of where all the people are, but the mean, or mu, is kind of the balancing point. And they show a picture of this, and I think I have it over here, so let me just grab it and bring it over, like what that looks like in when it's drawn better. If I can find it. Here. So here's kind of what they're pointing out is like, here is the median of this skewed data right there, the mean of this skewed data. The median is probably actually in this data. The median is probably going to be right over in here somewhere. So the mean is where this data would balance on a scale like that. Right? It's also, since I've got it over here, I'll just use it. It's also possible for you to have some strange looking graphs that have more than one point in it where you have a lot of data. So that's when you start getting these kind of bipolar graphs, or the ones that have these two areas where you could end up having most of the data, like the maximum amount right here. But we'll talk about those in another lesson. So that's the first thing, is just starting to understand a density curve and what the density curve is really being used for, and that is to find the area, which ends up being always 1, which we will interpret as being the percent of people, or the percent of individuals, percent of data points that are below or above a certain level.